Hello, ladies and gentlemen. Welcome back to Math 31, Calculus, Chapter 2, Lesson 5, the Sum and Difference Rules, Part 1. So today we're going to be explaining the derivative theorems for sum and difference, bracket f plus or minus g, close bracket prime of x equals f prime of x plus g prime of x. We're going to be explaining the sense of the derivative theorems for sum and difference using practical examples, and we're going to be differentiating polynomial functions using the derivative theorems for sum and difference. So, the sum rule, bracket f plus g close bracket prime is f prime plus g prime, or using Leibniz notation, ddx bracket f of x plus g of x close bracket equals ddx f of x plus ddx g of x. And the difference rule is the same idea. F minus g prime equals f prime minus g prime, or ddx f of x minus g of x is ddx of f of x minus ddx of g of x. So let's do some examples. Find the points in the curve y equals x to the fourth minus 3x squared plus 3 where the tangent is horizontal. Well, as we just said with the sum and difference notation, f prime of x, we chunk it. So we go 4x. What's the derivative of 4x? Well, that'll be 4x cubed. The derivative of minus 3x squared will be minus 3 times 2, or minus 6, x to the 1. And the derivative of 3 is 0. And I get too lazy to write that out. So f prime of x is 4x cubed minus 6x. Now, note here it says, find the points in the curve where the tangent is horizontal. That is, y prime is 0. So I want to solve for this. Now, y prime, f prime of x, either way, equals 4x cubed minus 6x. So where does that work? Well, let's do all one color. Now, 4x cubed minus 6x, I can factor out 2x squared minus 3, I believe. So, where does this equal 0? Well, 2x equals 0, or x equals 0. Or 2x squared minus 3 is equal to 0. 2x squared equals 3 over 2. X is plus or minus the square root of 3 halves. So I got three coordinates, 0, plus square root of 3, minus square root of 3. Now, before we go any further, I really should point out, wait, I'm right down here, do I have room? Yes. Now, square root of 3, square root of 2, I want to emphasize something. We really don't like leaving a radical in the denominator. So this is plus or minus square root of 6 over 2. Okay? That's important. Your calculus teacher in university will probably get upset with you if you don't do that. Now, the question is, we were looking for points or coordinates. So, we have some coordinates here. First, x equals 0. If x equals 0, what the heck is y? Well, plug it in. Y equals, the original equation for x to the fourth minus, I can't remember, 3x squared plus 3. Did I do that correctly this time? Good. Now, when x is 0, what's y? Y will be, or f of 0 is 3. So the coordinate is 0, 3. That's one point on the original graph where the tangent is 0. Now, the other points are, where is plus or minus root of 6 over 2, so f of plus or minus root 6 over 2. So that is plus or minus root 6 over 2 to the 4th minus 3 times plus or minus square root of 6 over 2 plus 3. Now, you notice here I'm cheating because I'm supposed to be doing this for plus root 6 and minus root 6 over 2. But notice they're both even powers, supposed to be even powers if I wrote it out correctly. So the minus signs cancel out. Okay? So, let me see. That becomes square root of 6, so that's 6 squared. So that's 36 over 16 minus 3 times 6 over 4 plus 3. Let me see. 36 over 16, that is 18 over 8. That's 9 over 4. Minus 18 over 4 plus 3. So that's 3 minus 9/4. So that is, or 8. I believe that's 3/4. Yes, it is. So the other coordinates are plus square root of 6 over 2 comma 3/4 and minus square root of 6 over 2 3/4. Now, as I said, I cheated. I really should have done this for a positive, and then for a negative. But since they're both all even powers, all the negatives cancel out. I can get lazy. Lazy is nice. I mean, economical with my energy. Now, let's do something slightly nastier. Differentiate this mess. X squared, bracket x minus x over square root of x squared. Now, right off the bat, this square is screwing everything up, so we have to FOIL this. Now, by this point, I don't always write this out, but I want to because I'm getting old. So minus 4 over square root x plus 4 over, yes. Okay, so far so good. Oh, sorry, I did screw that up. My apologies. X, so that would be 4 times x over the square root of x. Minus 4 over x, sorry. I am being all impressive trying to skip steps and I screwed up. Anyway, now, x divided by square root of x, that just simplifies square root of x. Let's write that 4x to the minus 1. Now, the derivative, y prime, which is f prime of x, dy dx. Now we check it. Derivative of x squared is 2x to the 1. The derivative of minus 4 x to the 1/2 will be minus 4 times a half, or minus 2x. 1/2 minus 1 is minus 1/2. And the derivative of minus 4x to the minus 1, well, that's minus 4 times minus 4, sorry, minus 4 minus 1 is plus 4, x to the minus 2. Okay. So far, so good. Now, as an aside, often you'll see, oh sorry, not often, but sometimes, x to the minus half, we write that as 2 over the square root of x. We might write it like that just to confuse you, get rid of the negative exponents. Some professors don't like negative exponents, some do. Oh, minus times a minus is plus plus. So that would be my apologies. Did make a boo-boo there. Let's see. Minus. Sorry, and a plus. Anyway. So, too many ways to make dumb boo-boos, but this is what I need you to be able to do. Any questions, shoot me an email. Otherwise, good luck.